To understand the distance formula, this is the formula for the distance d between 2 points in the plane, it's helpful to think about a right triangle. In this picture here, we have a right triangle that is connecting the points x1, y1 and x2, y2. If we think about slope in terms of rise and run, we would call the horizontal part of this triangle the run, and the vertical part the rise. And then the Pythagorean theorem gets us that run squared plus rise squared is equal to d squared. If we can just remember this, it's usually enough to allow us to fill in the details and derive the distance formula. This is a little bit more intuitive and easier to remember than the straight up formula. But looking at this formula now, we can see the difference between the x values, that's really our run, right? The difference between the y values, that's really our rise. And the reason for the square root is that the Pythagorean theorem gave us a d squared. We need to take the square root of both sides of this equation in order to get just d. So the distance formula is a lot easier to remember if we can think about it this way. It's the square root of a sum of squares where each term is a rise or a run, right? A rise or a run squared. So using this formula now we can find the distance between these 2 points. We'll call them x1, y1 and x2, y2 and plug into the formula. We start with a big square root and our first term is a run squared, so the difference between the x's, that's -4 minus 2 quantity squared plus the difference between the y's, which is -1 minus -5. We need to be very careful with signs here. When we have negative numbers and we're subtracting negative and positive numbers, we want to be very slow and not make a sign error. On this second term, we have a subtraction of a negative, which becomes plus. But I will note that both of these are squares, so by the time we've evaluated and squared the terms, they should both be positive. We never end up with a negative term inside this distance formula. The first one is -6 in parentheses quantity squared, and the second one is +4 squared, so that this becomes the square root of 36 plus 16. And we can see an exact and a decimal version of our answer. So when I combine these to get the square root of 52, I can just put that in a calculator for the decimal version. I don't have to simplify it first if all I want is a decimal. In this calculator, I would hit the 52, enter 52, and then hit the square root, which takes the square root of whatever is on the screen. We'll take that to 3 decimal places, 7.2111. But for the exact, we need to simplify the square root. To simplify this square root, I am going to factor out a perfect square factor. So 52 has a factor of 4 in it. Since 4 is the largest perfect square factor, that's how I'm going to break up the 52. The square root of 4 becomes 2, and the 13 has to stay inside the square root because it does not have any perfect square factors. So my exact value, we never get a decimal approximation if we're asked for an exact value. We want to keep it in this symbolic form if necessary and simplify it as much as possible. So this would be our final answer.